Hi everybody, Jamie Whitmer, nurse practitioner here. It is March 31st, 2020, and I've been sitting here today thinking about the World Health Organization's Solidarity Trial, and I thought I would share some of the things that I learned. The Solidarity Trial is a trial of 4 possible COVID-19 treatments. This is a big deal because as of now, there is no scientifically backed treatments for COVID-19. So the World Health Organization put together the four treatments that had shown anecdotally some promise in countries who had fairly large outbreaks already. And now they are doing this trial that will be a multi-country trial with the treatments that show promise. So the treatments are remdesivir, lopinavir and ritonavir, lopinavir and ritonavir plus interferon beta, and hydroxychloroquine and chloroquine. So remdesivir has 6 various ongoing trials going on, but the World Health Organization Solidarity Trial will far and away be the largest one that it's involved with. The medication is manufactured by Gilead. It's not commercially available. It was initially created for Ebola and Marburg virus. Unfortunately, it was disappointing in terms of Ebola trials, and there were other medications that were significantly more effective. How the medication works is it inhibits RNA synthesis and therefore keeps the virus from replicating inside the body. Per the New England Journal of Medicine, the medication showed some promise with SARS and MERS, both of which are coronaviruses that were somewhat fatal in the past, or were actually had a higher fatality rate than COVID-19 did, but they weren't quite as contagious. So the thing is, I guess the research limitation with remdesivir is that because of the way it works on inhibiting RNA synthesis, it probably or very well could be most effective early on in the disease process. And the way that the trials are set up now, and with testing being limited in so many countries, very often people aren't hospitalized and wouldn't be enrolled in a trial until later in the course of the disease process. So there are researchers that have mentioned that if remdesivir isn't effective in this early Solidarity trial, that perhaps researchers should give it a go in a trial that's focusing more on earlier disease process. Lopinavir and ritonavir is kind of the second thing that they're looking at. Lopinavir is an HIV drug that showed some in-lab benefit against SARS, and ritonavir is actually combined with lopinavir because it increases lopinavir's half-life through the CYP450 chromosome, which is very important for drug metabolism. So a lot of people that have metabolism issues or drug interactions and so forth, that's interacting or metabolizing through the CYP450 chromosome. And then lopinavir, ritonavir, plus interferon beta. So interferon beta is a medication used for multiple sclerosis. It helps to decrease inflammation, and it's also being trialed in MERS, or Middle Eastern Respiratory Syndrome, which is one of the other coronaviruses that's also fatal. There is risk with interferon beta in that it might carry the risk of actually increasing tissue damage if given too late in the course of disease. And again, this is a concern as the Solidarity trial may not be focusing on people earlier in disease, although that's certainly not part of the inclusion exclusion criteria for the trial. There's just researchers hypothesizing that so many countries right now don't have quite the testing that the robust testing that they need to catch the very mild or early cases. The last medication is chloroquine. This has been in the news as President of the United States mentioned that chloroquine and azithromycin had been effective against COVID-19 when in fact they hadn't been adequately trialed. Chloroquine was initially used as an anti-malarial drug in the 1940s and initially was very helpful to treat malaria. However, malaria became resistant to the drug over time, and it's no longer super effective against malaria. It's kind of one of these medications that every time a new virus comes along, it seems like we're talking about, let's try chloroquine. It is generally well tolerated, but it can prolong the QT interval, which is a measurement that we look at on EKGs in relation to heart rhythms. And if someone has a prolonged QT interval to begin with, the chloroquine can definitely make that worse, and that can lead to dangerous heart rhythms. So it's not 100% safe all the time. And of course, the dosing has to be safe and so forth. The Department of Health and Human Services in the United States is allowing for the medication to be prescribed to hospitalized teens and adults when feasible, even if a clinical trial is not available. Germany gave 31 million doses of hydroxychloroquine to the national stockpile, and Bayer gave 1 million doses of chloroquine to the stockpile. A 2005 study published in the Journal of Virology said that chloroquine could prevent the spread of SARS, which is another coronavirus that was found to be fatal. This medication as well interferes with blocking viral, or by slowing or interfering with viral replication. And it does so by blocking a process by which the virus acidifies its chromosomes, and this renders it less able to replicate. It also keeps viruses from attaching to a receptor called angiotensin converting enzyme 2, or ACE2, and this is also something that's necessary for viral replication. Preliminary tests in China and France showed that chloroquine could be helpful in the treatment of COVID-19. And then also the University of Minnesota, in an unrelated trial, is researching whether hydroxychloroquine alone, or hydroxychloroquine, is effective in terms of prevention of COVID-19. So that's kind of just the basics relating to the Solidarity trial. It's going to be very interesting to see how all that plays out and whether or not any of these treatments are going to be effective for the treatment of COVID-19.